But for those of you who are not familiar with me, again, my name is Mike Romanowski. I'm a licensed structural engineer. I'm actually based out of San Diego, but LA and Orange County is my primary territory. I also cover Arizona and New Mexico. I reach all the way up to San Luis Obispo. And by the way, I am a Cal Poly grad, class of 79, Arch E. Anyway, been with Woodworks for 4.5 years. For those of you not familiar with Woodworks, we are a nonprofit organization. We do a lot of education stuff like this, but we're also there to assist you on your projects. And that's really what our primary goal is, our top priority. And so I'm here as a resource to you. At the end of the presentation, and also I think in the chat box, you can get my email address now, but it will appear on the last slide. If you're interested in getting a PDF of this presentation, I'll be happy to send it to you. If anybody would like a certificate of completion just to put in your file or hang on your wall or whatever you'd like to do, I can provide that as well. You just have to send me an email. We are an AIA CES approved provider. So if you can give me your AIA number, we will take care of registering this presentation for you. This counts for one health, safety, and welfare learning unit, but you just have to send me an email afterwards and I can take care of all that for you. So with that, without any further ado, let's get started here. Last time we talked about a number of different mass timber products. So CLT was among those. That's the most popular one. But also we talked about a number of other ones. Today, what we're going to talk about are the upcoming tallwood provisions. These were originally coming into the 2021 IBC. We'll be talking about what drove that, some of the history behind it. But then we will finish the presentation by talking about specifically what is going to be different in the California version. And as everybody knows, because we're special in California, we have to have our own code and we have to tweak it slightly. So our California provisions will not be exactly the same as the IBC provisions. The good news is the types of changes are consistent with the way California has been doing it for all other types of construction in terms of the way they treat a certain few occupancies. But anyway, we'll go over that at the end. The good news is rather than waiting until a 2022 CBC to come out, California has decided to be early adopters of the tallwood provisions, and they are going to bring them out in the 18-month revision cycle or the amendments to the 2019 CBC. And so they were voted on this past August. They've technically been published. I haven't tried to go to the ICC website yet, but they were supposed to have been published January 1st of this year, and they will be adopted July 1st of this year. So let's get started. We'll talk about, again, the whole first part of it will be about the IBC, how it came about, and then we'll finish up with the differences with CBC. Again, we're an AIA approved provider. Here's some things we have coming up on the education side. We just did a presentation, a webinar this afternoon or this morning Pacific time on 2 big mass timber towers that are going up. I don't know if anybody had the chance to attend that. If you didn't, but you're interested, we have archives of all of our webinars. You can go to our website and take a look at those. The presentation today was about the Intro project in Cleveland and the Ascent project in Milwaukee. Both of them are under construction. They are mass timber projects. When Ascent in Milwaukee is finished, it will be the tallest mass timber building in the world. There is a 280-foot tall one right now, I believe in Norway, but we will take the lead on that one. Who knows when that'll be eclipsed, but anyway, that's what that presentation was about. In February, I've got something coming up about a mass timber project at Michigan State University. And then we also have some online workshops on February 23rd and 25th. These are actually 4 different workshops. They're looking at case studies of 4 specific buildings. So on February 23rd, there is a 2.5-hour presentation in the morning on one case study. Again, in the afternoon, there's a case study on a different building. And then the 25th, there's again one in the morning, one in the afternoon. But feel free, go to our website if you'd like to sign up for these. The webinars are always free, and then the workshops, there is a cost involved, but it's pretty minimal. So here's our course description. Again, U.S. building designers have been interested in tall wood for a while, but U.S. is basically 10 to 15 years behind the rest of the world, Europe in particular. And so a lot of the building designers in the U.S., they wanted to do these tall buildings, but there was nothing in the code to do that. And the only way you could do it then was like a project-specific performance-based design. We call that the alternate materials and methods request. It's 104.11 in the code. But what happened was, ultimately, ICC said we need to catch up. They had an ad hoc committee formed. They did some testing, all this research. They come up with their recommendations for the 2021 IBC. This will allow up to 18 stories of mass timber construction. We'll actually introduce 3 new types of construction, 4A, 4B, and 4C. But then the California Building Code will also be early adopters of this. These will come out, like I mentioned, in the 18-month revision cycle, which will be adopted on July of 2021. So the outline of the presentation today, we'll talk about what went into the IBC provisions, and then we'll finish up with what the difference is in the CBC things at the end. So here's our learning objectives today. We'll talk about some global history, what's going on in the world. And again, right now, most of it has been overseas in terms of tall wood. Very few tall wood examples in North America, but we'll explore the work and conclusions of this ad hoc committee, going over a number of the new recommendations they had that will go into the 2021 IBC. We'll talk about the new different types of mass timber construction, existing construction types as well. And then I'll finish up by identifying the differences between the IBC and the CBC versions as far as tall wood goes. So some of the questions we'll answer: what is tall wood? How tall is tall? What's been done so far? What products are used? And we kind of went over this last time in the last presentation. What does the code allow right now? How did we arrive at these changes? And then what are these new provisions here? So before we get too far into that, I just kind of want to go over a little terminology here. Everybody's pretty familiar with the term heavy timber. We've got a type of construction in the code right now. It's just called type 4, also called heavy timber. You'll see that term used quite a bit. But in the past, been around for over 100 years. It's all based on the fact that wood, large wood members, or any wood members, they char at a very predictable rate. And that char layer actually then creates an insulating layer for the remaining core of sound wood. And it was found out early on that if you built a building of what's called heavy timber, which was large members, it didn't just all go up in flames at once. It would burn, but it was very hard to get the fire to start burning in heavy timber members. But even if you had a fuel load burning against it, it would char at this predictable rate and it would stay in place. And if you had large enough members, you could exit the building safely. Firefighters could enter the building and fight a fire safely. And that's what the whole heavy timber requirements, how it came about. But back 100 years ago, if you wanted a 16-inch square column, you had to go to the forest and find a tree that was that big. And so that's kind of the picture on the left is traditional heavy timber. The columns, beams, and even the decking you see, all of that is solid sawn individual pieces. Even if it's a 16-inch square column, it came from one tree. The difference is mass timber is a type of heavy timber. It's generally large wood pieces. It chars basically at the same rate, but now it's made from all smaller pieces. It's either laminated with glue or mechanically laminated. And so glue lams were kind of the first mass timber element. Everybody's familiar with this. You can see an example of this from the Bullitt Center up in Seattle. Got glue lam columns, glue lam beams. The floor here is something called nail laminated timber. If you remember that from the last presentation, that's a type of mass timber. NLT is the acronym we use for it, but it's basically 2x set on edge and nailed together with no space between them. So again, these are all made from smaller pieces, but the whole word mass timber comes from massive pieces or panels of timber. What is going on in the real world out there? Well, here's a completed project, and this is the one right now. It is the tallest mass timber project, called Mjøsterne in Norway. It's 280 feet tall, but notice it's only 18 stories. So they had a pretty good floor to floor height here to get to the 280 feet. This is a completed building. There's another project called Ho in Austria, which is, look at this, 24 stories. That's 6 more than Mjøsterne, but it's only 275 feet. So they had a closer floor to floor height. It's technically not the tallest in terms of feet, but the tallest in terms of number of stories. So again, both of these are not in the United States. These are Austria and Norway. The closest one we have to us right now is the Brock Commons project, which is up in British Columbia. It's at the University of British Columbia. Again, this is 18 stories, 174 feet. It's actually 17 stories of mass timber on a 1-story concrete podium. Maybe a few of you have even seen this. I got to visit the site the last day that they were flying the last wall panel into place. But what's interesting here, you know, it was the speed of construction that was the big driver on this. It went up real fast, but the end product, there is not 1 inch of exposed CLT. Everything is totally encapsulated. And what you'll see, and we'll talk about this later, this pretty much mimics the new type of what's called 4A construction, which is fully protected mass timber. Now, in terms of what we have as an example of a tallwood building in the United States, I can count them on one hand, and I can actually count it on one finger. It's the Carbon 12 project. This is the only example of what we would call a tallwood mass timber building in the United States. It is completed. It's 8 stories. It's only 85 feet, which is allowed by current code, but you can't have 8 stories of wood under current code. This is 8 stories of mass timber, so it's outside current code, but it is very similar to one of the new construction types, and we'll talk about that. But that's what we have for an existing example. Now, here's this Ascent project. I mentioned this earlier. This is under construction right now. They expect to, they're just in the ground. There's several stories of subterranean parking. They'll expect to have mass timber on site. They'll start erecting in May of this year. So keep your eyes open, your ears open for the Ascent project. Again, when it's done, 285 feet, it will be the tallest mass timber building in the world. I believe it's like I want to say about a 6-story podium and maybe 19 stories of wood or something like that, but still be a pretty spectacular project. The other one that was covered in the presentation today was Intro in Cleveland. Again, this is 9 stories, 115 feet, a little more modest. It is outside today's code, but sort of fits the requirements of the new code, the upcoming code. I will mention, however, that both the Intro and the Ascent, neither of them completely meet the new code. They are both slightly outside of even the new code provisions. They definitely had to get it approved through that alternate materials and methods request, but they did. And both of these are under construction. Keep an eye and an ear open for them. They'll be very interesting to follow. One other interesting one is a 3-story overbuild project. This is in Washington, D.C. And what this is, an existing 7-story concrete building, I believe is only designed for 1 additional story for future expansion. But what they realized is the weight of mass timber is so significantly lower than a concrete building, they were able to add 3 full stories of mass timber instead of the 1-story original in concrete. So this is another option, not real popular yet, but it's called overbuild. This is going to be going on in Washington, D.C. right now. So in terms of materials, I think we touched on this briefly, so I won't spend too much time. We touched on this last presentation. Glulam is the one you're probably most familiar with, cross-laminated timber. You will hear the most about this. It is the most popular of the mass timber materials. Quite a few people come to me with questions. They ask questions about mass timber, but what I realize what they really mean is they're only talking about CLT. You do need to remember there are other types of mass timber. And so one of those, and this is in the upper right corner, is nail laminated timber. Again, these are your 2x joist, stood on edge, no space between them. nailed through so they're all joined together. This is actually covered under the current code, and it's been in past codes. It's called mechanically laminated decking. It is in the code, it's just not called nail laminated timber. But that is a type of mass timber. It's what they used in the T3 building, which is what you see the picture of in the lower right corner. Some are similar to nail laminated timber is DLT, dowel laminated timber. Now you're using hardwood splined wood dowels to join these pieces together. Big difference here is nail laminated timber is basically construction lumber type material, has eased edges, various imperfections in depth and all that. Nail laminated timber, everything is milled before it goes together, so it's extremely tight tolerances, all exactly same width and depth, much more polished looking material. But they can also, because it's milled ahead of time, they can come up with some very interesting reveals and all that are really good for acoustics and all. So it has an appeal from that respect. Again, this is dowel laminated timber. Another type of cross laminated timber is MPP, or mass plywood panels. It's approved under the CLT standard. It's just, instead of using solid sawn lumber, it's essentially using LVL lumber, which is made from veneers. So that's why it essentially looks like a big piece of plywood. This is the new kid on the block in mass timber. If you hear about MPP, that's what it looks like. The face of it looks different from CLT, because CLT, you'll see the lines like every 6 inches or so if it was 2x6 lamina, where the MPP has whole 4 foot wide width, so it looks like a piece of plywood on the underside. And then TNG decking, you are very familiar with this. This is considered a type of mass timber element. It is used as the floor elements in a number of mass timber buildings. It can be 2x, 3x, 4x, variety of thicknesses. So the question is, why tall wood? Well, global population, that's one of the big drivers. 7.6 billion is our population right now, but projected to be 9.8 billion, a 30% increase by 2050. Well, this rock that we're living on is not getting any bigger, but if we have more people and more people need more food, we have to have room to grow the food too. And while they may someday figure out how to grow food in a high rise, for right now, what needs to happen in high rises is that's where we have to live. So we have to grow upward instead of outward to accommodate this global population boom. We're going to look like the Jetsons. You remember what that looked like? Everything is a tall building, and we fly around between them in our little cars. Here's a good graphic then that kind of illustrates that. You can see what the green or rural population has been doing since the 50s. It's actually been declining, and it's projected by 2050 it'll be down to 42.2 million. The urban population, which is in red on the other side, look at how it's climbing, and look at how it has outgrown the rural population. This is what we need to accommodate. So again, going upward versus outward is our choice. And mass timber, we really see the sweet spot for that is going to be in that 6 to 18 story range, which is exactly what these new construction types under the new tall code provisions will be providing. Here's an example, the Brock Commons building I mentioned before. One of the reasons that mass timber is a good alternative in today's, environmental issues are popular, greenhouse gases, carbon sequestration, all that. One of the real benefits of wood, not just mass timber, but mass timber much more than stick frame, is wood sequesters carbon. All the carbon that it cleans while it's growing in the tree, it expels all that oxygen, which we like, but it holds on to the carbon. And so 50% of the molecules in a piece of construction lumber are carbon. That's the equivalent amount of carbon dioxide that did not get released into the atmosphere. It's also a very environmentally friendly building material in terms of greenhouse gases emission. Compared to other popular building materials, it's a fraction of the greenhouse gases. And so as an example, on the Brock Commons project that used about 2,200 cubic meters of CLT and glulam, that takes 6 minutes for US and Canadian forests to grow, but the carbon stored in the wood was over 1,700 metric tons. The avoided greenhouse gases, almost 700 metric tons. That's about 2,400 metric tons of CO2 that did not get into the atmosphere. That 511 cars off the road for a year, energy to operate a regular home for 222 years. So again, real economic or environmental advantages to mass timber. That's one of the drivers. So what are the market drivers for mass timber? Well, one of the biggest ones is the construction efficiency and speed, particularly if you compare it to a cast-in-place concrete building. That Brock Commons project, they were able to erect one entire floor of CLT in one day. They put all the columns up, the glulam columns, the next day, and they erected all of the exterior offsite fabricated wall panels the third day, and it all started over. That probably wasn't the order they did it in, but it's way faster. That Brock Commons project that had 17 stories of mass timber, they were able to erect all 17 floors in 8.5 weeks with a crew of 8. So it was 3 days per floor, working 6-day work weeks with a crew of 8. It was amazingly fast. And so that's one of the drivers for mass timber. All these parts are offsite fabricated. So construction site restraints, particularly in an urban infill area where you don't have a lot of room around the project. You don't have room for what you call a laydown yard where you can store materials. Mass timber project, you're not storing materials. You don't store the CLT or the mass timber elements on site. They arrive on site on a truck. You pick them off the truck, fly them into place right then. And so speed is big, but also the site restraint thing is big. That's a real driver. And then one of the biggest as well, if you've heard of the term biophilia, the beauty of wood. Wood just has a natural, because it's a natural element. There have been tests done where if you're in a room with wood compared to drywall or concrete or steel, your blood pressure goes down, your stress level goes down. If they give you the same test, you'll test better in the room that had the wood in it. So there's all these other kind of hidden effects called biophilia, but it's beautiful. You rarely would see people hug a concrete column, but we've seen people hug wood columns. It's like hugging a tree. So it's a very real thing. Some of the secondary drivers, and I touched on this before, the carbon reductions, but also structural performance. It's lightweight. It weighs about 25% the volume per volume of concrete, which when you're doing a high-rise building, if your dead weight of the building is that much lower, what does that equate to? Well, less cost in the footings. Maybe you can use conventional footings versus a specialized footing, smaller conventional footings. Also in California, where seismic is a big concern, seismic is directly related to mass. So if you have a lower mass structure, it has a lower seismic demand. So there's cost savings there as well. So number of things like that drive the market. Let's talk about US building code status then right now. So currently, and again, this is still current IBC, current CBC, even though the new revisions to the 2019 CBC have been published, they won't be adopted till July. So current building code status right now says for wood construction, and this is type 3, type 4, type 5, 6 stories with a B occupancy or 85 feet. That's the absolute upper limit. If we're talking R occupancy, residential occupancy, that's only 5 stories and 85 feet. That's in type 3 construction. If you want to go over 6 stories, then really your only choice has been this alternate materials and methods request, or AMMR, as we call it, through a performance-based design. And again, this is allowed by code. It's 104.11 in the code, but there's always more hoops to jump through to do this. That's what designers have done so far to do tall wood in the United States and Canada. And interestingly, all this stuff—
Mike, how many buildings have pursued the alternate route in California? 0.
The only one that's—
the only one is the one
the
in Portland.
Carbon 12
Wow.
in Portland, exactly.
Are you
That's
aware of any that are attempting to pursue?
Oh, absolutely. Absolutely. I mean, we have one in, I can't give you the name of it. It's right in LA. It's been planned for 2 years now. They knew the changes were coming. They're sort of just sitting and waiting for those changes to be adopted, but they want to do a 12/2. So it's going to be, we'll talk about it in a little bit, but it'll be type 4B construction over a 2-story concrete podium. But all those are in the preliminary stages. The Brock Commons building was done prior to IBC even being adopted. It was in under a Canadian code, but it was done essentially through the AMMR process. Again, performance-based design where you demonstrate equivalent life safety to do it. European codes, on the other hand, have started adopting this. I honestly don't know the whole story in Europe, whether the pictures I showed you of Yostrone and HoHo, if those are actually under current code or if they were AMMR, but their codes have already been adopted for tall wood buildings.
I'm curious why the number's 0 right now. If, for example, with high-rise steel structures, or a lot of times they go a performance kind of route.
And again,
is what you're here? I've never worked on one myself, so my knowledge is very small, but I'm curious if what you're hearing is part of the issue is that those that are maybe peer reviewers or something assigned to it are not as knowledgeable, or
it's not that they haven't been approved, it's nobody's been trying it, because basically what the jurisdictions have said, until the ad hoc committee actually got their act together and started doing some testing and all, there wasn't enough information out there. And as you know, the height and area of building is not driven by structural per se. It's fire issues, escape time, all that. So it was the state fire marshals that were saying, you want to do wood, 18 stories? Whoa, no way. Wood was just, that was death. No way. You can't do that for fire purposes. They didn't understand, because in their mind, wood is light frame, stick framing, which is like kindling. Admittedly, when it's haven't been protected with drywall and stuff, it will go up fast. That's why we have to protect it with drywall. But that's why we also can get away with not protecting mass timber, because it has that inherent capability. And once that point got driven through to the California State Fire Marshal, believe it or not, when these new code provisions for California came up, you know who it was that submitted this to the California State CSBC, what does it stand for? Building Standards Commission? It was the state fire marshal. They came on board with it, and they had reasons, and I'll show you at the very end why they're on board with it. So it's kind of interesting. We're early adopters, and those provisions were put forth by the fire marshal for adoption. The ICC doesn't just say, well, let's do this. Somebody has to tell them, we want to do it, and here's the reason why. So that's the situation right now. It's been the fear of wood up until now, even though they were doing it in Europe. It's like, hey, our building departments, there just wasn't enough local research and testing. Now there has been, and there are several states like Oregon, Washington, they've already adopted the tall wood provisions for IBC. It's within code now because they're on board with that. But what's common up in those states?
How long has the alternate path been out there for everyone in code?
As long as I've been practicing since '79.
That's why I'm surprised then that the number is 0. That one's.
But I'll be honest. Until I joined Woodworks, I had never done a project under this. I didn't even know this existed. That it was a path to go. Yes, it's more hoops to jump through, but that's how you did it. And so again, mass timber only came into popularity. It first appeared in Europe in the early '90s. It's kind of a college study type thing. Then they started, hey, this is kind of interesting. We should do buildings out of this. And so they started getting on board, getting their codes changed, but it just didn't catch up in the US. We're about 10 to 15 years behind it, but we are catching up. And so within a few years, we will not only have these height and area provisions adopted, but we'll have some additional structural openings for using CLT like as shear walls. Right now, that's not approved. It will be coming in future code. So in the future, you'll see these tall buildings that may be all CLT, walls, floors, you name it. Right now, you can't really even do the walls because it's not approved as a shear wall, even though these code provisions are allowing, for a height and area standpoint, for fire safety, they're allowing it. You're going to have to use a different lateral force resisting system, concrete shear walls, moment frames, that type of thing. Okay, so within the code 2015 IBC, this is where it first appeared. CLT was really the catalyst for this, but it appears here, it's defined, and then they refer to APA PRG 320. That's the standard, just like the product standard for plywood or glulam or whatever. So any manufacturer to use their product under the IBC in the United States, they have to meet this PRG, they have to have PRG 320 approval. So some of the European manufacturers, there's at least 3 that are selling product in the US that meet this, but not every European manufacturer necessarily does. All the US manufacturers do, because they know that's how they sell their product in the US, is to have PRG 320 approval. So let's talk about then, the ICC ad hoc committee was formed in December of 2015. This is when ICC said, we got to get moving on this. They had 3 objectives then: explore building science of tall wood buildings, investigate feasibility of tall wood, and then take action on developing code changes. They had these 6 objectives, and the first 2 are really the most important. So number 1, and this is absolute most important, no collapse under reasonable scenarios of complete burnout of fuel without automatic sprinkler protection being considered. So number 1, obviously the structure cannot be part of the fire. If it's made of wood, that's fine, but it cannot contribute to the fire. And so assuming that you had no sprinklers or they didn't work at all, if you had this fully loaded unit or units or whatever with furniture, whatever, that's the fuel load. If for whatever reason that caught fire, it has to self-extinguish. So that's the testing and research. That's what they were looking into. Objective 2 was, notwithstanding objective 1, we're going to make you put in highly reliable fire suppression system to reduce the risk of failure, again, during reasonably expected fire scenarios. And the degree of reliability then was directly proportional to the evacuation time or height. You don't use the elevators, you have to come down the stairs. Firefighters have to go up the stairs. So taller the building is, the more protection you have to have. And that's the same rationale for type 1A construction and all that right now. These 2 objectives, 3 and 4, basically say that for the outside skin, you can't have any unusual high radiation exposure to adjoining properties under a reasonable fire scenario. And so if your building is on fire, it can't just jump out the wall and catch the building next door on fire. And then objective 4 is, if the next door neighbor's building is on fire, it can't jump through the wall easily and catch your building on fire. So again, those are objectives 3 and 4. And then the last 2, and probably the most minor, but I mean, these are equally important: no unusual fire department access issues, egress systems designed to protect building occupants during the design escape time, plus a factor of safety. So these were their 6 objectives. They came up with a test regimen then. They commissioned a series of 5 full-scale tests on a 2-story mass timber structure at an ATF facility in 2017. This is kind of what it looked like. It was a little 2-story, all CLT building, had some glulam columns, some glulam beams. This is what it looked like. It's in a big warehouse building, a big tilt-up building, or maybe it's cast in place, but a big test facility. You kind of get the scale, the size of the man here. And I'll go back. The test setup had a corridor around it and a stair shaft in the back, and then a living room, bedroom, same layout for the upstairs and downstairs. This picture here, they haven't built the corridor around it. Can't tell if they built the stair shaft in the back yet, but this is what it looked like under construction. This is all the CLT pieces. And then here's what the 5 tests were going to look like. The first 2 the first 2 are the one where number 1 is all mass timber surfaces protected with 2 layers of 5/8 gyp, no sprinklers. Okay, so this kind of mimics what will be the new type 4A. We'll talk about that in a little bit, but basically no exposed mass timber, but no sprinklers either. Test 2 was similar to what we're going to call 4B. That's the one where now you can expose some of the mass timber. So in the test case, they exposed 30% of the ceiling area in the living room and bedroom. Again, no sprinklers. Test 3, instead of exposing the ceilings, they exposed the walls, but again, no sprinklers. Test 4 was all mass timber surfaces fully exposed, but this is like the baseline where you do have sprinklers and it's normal activation. And then test 5 was similar to 4, fully exposed, except we're going to delay sprinkler activation by 20 minutes and see what happens. So here's what test number 1 looks like. And I want to stress to you, in all of the photos I'm showing you, usually the second and third slide where we call flashover, this is when essentially the fire is exploding. This is not the structure burning. This is not the mass timber. This is the fuel load. It's the beds, the furniture, the tables, the kitchen cabinets. They even put little wood pallets in there to increase the fuel load so they could get this huge inferno burning in the unit, but this is not the mass timber burning. So pictures 2 and 3 are flashover. The fourth picture down in the lower left corner, this is called decay phase. Again, this is with no sprinkler activation. Pictures 4 and 5, this is what it looked like after the thing. Some of the drywall isn't even blackened. But again, no sprinklers, it burned itself out. That was the objective. Doesn't catch the mass timber on fire. It self-extinguishes with no sprinklers whatsoever. Test 2 now, and if you look in the lower left corner, this is the one you can see at the best. This is where they expose the ceilings in the bedroom and living room. Again, upper 2 in the right corner, this is flashover. We get into decay phase where the fuel is burning out. You look in the lower right corners, this is the exposed ceiling. Again, this is exactly what they expected. Wood chars at about 1.5 inches per hour. It did char. It protected the remaining CLT that was sound material above that, and the fire still self-extinguished. The timber itself, the mass timber, did not contribute to the fire. It was charred due to the fuel load, but that's all. Okay, test 3, very similar. Now we're talking walls. The photo in the lower left corner shows the exposed wall. Again, flash over in the upper right. You can see what they look like here in the lower right. Again, some of the drywall did look a little more distressed on the ceiling. I don't know what the reason for that was, but the structure never caught fire and it still self-extinguished. Test 4 now is like the baseline one. This is where we have sprinklers. They always lit the fire. The point of ignition was back in the kitchen. The fireman went back there with a propane torch or whatever, a gas torch. They would light it. Within a few minutes, the sprinklers activated. Nothing happened. So this is what we would expect with normal sprinklers in it. And this is the delayed activation one where they waited 20 minutes. It never got to full flashover, but it started to burn, and then the sprinklers, after 20 minutes deployed, it extinguished, and none of the mass timber contributed to the fire in any of these cases. So while this was going on, there was also some testing unrelated to the ad hoc committee, but they were testing some of the CLT. One of the things they did find was there was an issue with the early types of adhesives in CLT, that if you were testing a horizontal surface in a fire, you'd have this charring going on, but when the fire depth reached the adhesive layer, the adhesive gave way. It was heat sensitive, and you dropped that char layer and exposed some clean wood. So the ad hoc committee in the code recommendations said you do need to comply with the new product standard, which in that product standard, they require the new type of adhesive that is not heat sensitive. So even though they didn't test for this, they incorporated that testing, the findings from that testing, in what's in the code. And the way they did it is they said you have to comply with PRG 320-18. It's the 2018 version of it where they changed the adhesive requirements. So here's what the new provisions, the proposals look like. The 3 main ones we'll be concentrating on is in the upper right corner. New table 504.3, 504.4, 506.2 for allowable heights and areas. Other things in there, not so important, but obviously they were all incorporated. After all this testing, they proposed the changes, was all voted on, public voted on it. It all passed. Final votes were ratified January 31st of 2019. At that point, it was a given. We knew that the 2021 International Building Code would have these tall wood code provisions in it. Subsequent to those 14, those were called the Group A proposals. There's another, just 3 small things in Group B proposals. These were also subsequently approved. These mainly had to do with inspection and protection of connections and all. So what has changed? Well, as everybody knows, there's basically 5 main types of construction. All of them have an A and a B, which means A, fully protected, B is not protected except for type 4. There's no real fire ratings per se in type 4. You just meet minimum prescriptive sizes, and it's deemed to provide adequate fire protection. Okay, so in those categories, when I'm from Woodworks, I'm mainly used to working in is 3, 4, and 5. 3 and 5 are really the light frame, stick framing. Type 4 is the old heavy timber, or this is where mass timber also fits in. Although mass timber can absolutely be used in types 3 and 5, as it is approved for that. But now you do have to do calculations, or you have to provide fire ratings, where if you met minimum prescriptive sizes for mass timber in a classified as a type 4 building, you didn't have to do any, you didn't have to have fire ratings, you just met the minimum prescriptive sizes. So here's what the new code's going to look like. We're going to have these new type 4 construction types. They are going to be A, B, and C. So A, like in the past, fully protected. B is now partially protected, and C is like no protected, like the other B category was in the other construction types. And then they are renaming the old type 4 HT, just so it has its own little subscript to make sure it's clearly different from the other A, B, and C. So there's now a 4A, 4B, 4C, and a 4HT. The new building types, then, they're going to have some allowable heights and areas. And so as an example, this is not everything that the new code, but as an example, using B occupancy as an example, for type 4A construction, you'll be allowed 18 stories, a building height of 270 feet, and an allowable total building area. This is not the per floor area, but the total area, 972,000 square feet, so almost 1 million square feet. Now, if you broke this up over 18 stories, that would be 54,000 square foot per floor. You're allowed much higher per floor. It's basically, you get to take, 3 times the whatever the per floor area, that's the maximum of the building area for B occupancy under the IBC. That's where the 972,000 square foot number came from. So that's 4A construction. 4B construction, again, this is the partially exposed. Now we're going to be capped for a B occupancy at 12 stories, 180 foot building height. Total building area will end up being still over 500,000, 648,000 square foot. Actually, the same allowable area per floor, because we're back to 12 stories max now, but average 54,000 per floor. And then 4C, which is essentially fully exposed mass timber, for B occupancy will be at a 9-story limit, building height of 85 feet, 405,000 square foot total building area. What does 4A look like? Well, Brock Commons looks a lot like what 4A would be. So it essentially, it's 18 stories above, no more than 18 stories above the ground. It's 17 above the podium. The overall building height wouldn't exceed 270 feet. I don't believe it does. And then whatever the allowable area is, I don't know what Brock Commons is offhand, but it would have met those two. So that's what it looks like. Again, it's fully protected, so you're not going to see any of the CLT. When you go in the building, all the glue lams are wrapped. The underside of the CLT is wrapped. Everything is fully protected. For 4A, then, how much protection versus how much exposed? Again, fully protected, 0 exposure. This is the typical detail around a column where they have a glue lam column, comes up, it has a little steel, I call it a plug column in between. The CLT comes in, it's notched at the corners, bears on those bearing plates. The walls that go between the glue lam columns are made of light frame steel construction. Again, one of the things I want to remind you, and I'll say it again, and I'll say it again, the type 4 types of construction, 4A, 4B, and 4C in the new code, while they allow you to go above what we could do with light frame wood, there is absolutely no light frame wood allowed in 4A, 4B, and 4C. Not even non-structural, non-bearing walls. That's too much of a fire risk. So there are people who thought, oh, let's get away from 3A and let's do 8 stories of multifamily in mass timber. Well, that's fine, but you're not using light frame wood stud walls. You're doing something else. So no light frame allowed. This is an example. Between the columns, we had light gauge steel with the 3 layers of drywall protecting everything. Here's what the new code then says for different occupancies. Let's use B as an example. I mentioned this before. 18 stories, 270 feet. The area per story can be 324,000. IBC says your total building area, then you get to multiply that by 3. We're at 972,000. So we have some different occupancies here, A2, M, and R2. These are all the IBC numbers, but the reason I highlighted A2 and R2 in red is I just want to alert you, this is what's different in the CBC. And we're going to talk about that at the very end. So again, what I'm giving you here are the CBC numbers. These numbers are affected by CBC. We'll talk about that later. Okay, so what does 4B look like? Well, there was a project called Framework. It was an award winner in the USDA mass timber competition a couple of years ago. They got permitted, they got all ready to break ground, and they realized that the budget, they forgot to account for the demolition of the existing building. So they're still in the process of trying to work that out. We have our fingers crossed that they will work that out, and we will get to see this. This is up in Portland. But again, this is a 12-story building. This would essentially fit into that 4B category. Was never constructed. The one real interesting thing about this from a structural standpoint, and this is what they roughly spent most of their $1.5 million prize money on, was this what's called a CLT rocking wall shear wall system. So it had these center CLT shear walls. It has a post-tension rod at the center, which brings these walls back to plumb at the end of the earthquake. So it's pretty innovative. They have used this in another building up in Portland, even though it's outside code per se. They did it through the AMMR process. It wasn't a tall wood building, but they did use this rocking wall system there. But that's what 4B would look like potentially. Now in this one, again, 12 stories, 180 foot, 650,000 square foot allowable building area. The requirements now by code are 20% of the ceiling or 40% of the wall. And there are some formulas how you can do a weighted average between the two. But again, this is a good example of what it might look like on the inside. Columns like this don't count in the wall calculations, but when you have it like a beam above here, that does count as part of the ceiling area. So if all you were doing is exposing the ceiling, you'd look at your floor area. If that was 1,000 square feet, I'd say, well, I can do 200 square feet of exposed ceiling. It's not 200 feet of exposed CLT or whatever the mass timber floor element. You have to count the area on the sides of the beam and the bottom of the beam as well. So a little intricacy there, but again, 20% of ceiling or 40% of floor, or a combination of the two. Here's the allowable heights and areas. Again, same kind of thing. What's in red is what's affected by the CBC. You'll notice that these are A and R occupancies, and I'll talk about that. There are special occupancies that CBC treats different. These are 2 of them, but the B and M occupancies are no different from IBC. Here's our allowable heights, 180 feet, 12 stories for some occupancies, mercantile only 8 stories. Here's our allowable areas. Okay, now let's move to 4C. What does 4C look like? It looks like the Carbon 12 project. It's the one built project that would be considered tall wood right now in the United States. It is a completed project up in Portland. So now what you can see, the glulam columns are exposed, the beams are exposed, all of the ceilings are exposed. They did not use CLT as their wall elements. For the lateral system, they use buckling restrained brace frames and then non-combustible metal stud construction in their wall. So your exterior walls you see covered in drywall or whatever, but essentially all the mass timber is exposed here. Protection versus exposed, then basically the code says you can expose everything with the exception of a few items such as shafts, concealed spaces, and then there's a blanket requirement for the outside face of exterior walls having to have a layer of 5/8 inch type X or 40 minutes of non-combustible protection essentially. Here's our allowable heights and areas. You can see they're going down further. The interesting part is the height in feet is no different what's in the code now for type 3 construction, still at 85 feet. The mysterious part to me is they said, oh yeah, B occupancy, you can go 9 stories, but you're capped at 85 feet. Beyond me how you do a 9-story building in 85 feet, but the code allows it. Otherwise, looking at residential, we might be capped at 8 stories. Assembly, like a restaurant, 6 stories, but still we've got that 85-foot limit. The areas are commensurate with that. They keep going down. Again, the items in red are the ones that are different for California. We'll talk about that at the very end. Let's do a little, talk a little bit about then the fire resistance ratings themselves. And this is sort of some stuff you're familiar with from table 601, but not with the new construction type. So primary frame, this is the type of things that if they were to fail, this would affect, you could potentially have a pancake failure. It supports other levels of framing, such as beams that support more than one level, bearing walls that support multiple levels. So in 4A construction, it's required that you have a 3-hour rating at your primary frame, 2 hours if it's at the roof. In 4B, it goes back to 2 hour, 1 hour at the roof. Same thing for 4C. Floor construction, we have those types of ratings, like in table 601, except now it's 2 hour requirement across the board for all types. Roof construction, 1.5 at the roof for 4A, 1 hour, 1 hour for 4B and 4C. Something new here, the floor surface protection for 4A and 4B, which is the fully protected and partially protected, you're going to have a minimum 1-inch layer of non-combustible protection on the top. Now, fire is never assumed to occur on the top side. The reason they want this is when the fire is below, if there's any possible gaps in the joints between the CLT or whatever, or your mass timber elements, you want to make sure by having that non-combustible protection that prevents any fire or smoke from going up through those gaps. That's true for 4A and 4B. 4C, however, says no such requirement. Now, in all likelihood, you're always going to want to put a cementitious topping on your mass timber floor, because mass timber is made structural wood that's used in CLT or NLT. These are all softwood lumber. They don't stand up real well under foot traffic, chairs, rolling wheels, that kind of thing. That's why we use hardwood flooring. So you'll almost always have a non-combustible protection like gypcrete or structural concrete on top. And then roof construction protection, rather than requiring the non-combustible protection on the top in 4A and 4B, they just say you have to have 2 layers of 5/8 type X gyp on the underside. But 4C says no protection unless you have a concealed space there. Let's talk about the materials and protection then. Exterior walls, like I said, doesn't matter the construction type. All of them require 1 layer of 5/8 type X on the outside. Just as an aside, CLT as a mass timber element, the most popular one, is absolutely not approved for direct weather exposure. So even if it were ultimately approved as a shear wall, you cannot expose the outside face of the CLT. So the fire requirements are going to require you to put a minimum 1 layer of 5/8 type X on it, but just using CLT, you can't expose it to weather. So you're going to protect it somehow. Again, and I'll point this out again, what structural materials are allowed? 2 things, either mass timber or non-combustible. You do not see light frame wood in here. It is not allowed as a structural material in 4A, 4B, and 4C. Now, what about concealed spaces? In the past, type 4 construction, you couldn't have it, but they're gonna allow it in the tallwood provisions for 4A, 4B, and 4C. It's permitted, but it does require certain non-combustible protection on the mass timber surfaces. And then kind of got a new thing here. We can do calculations to show based on charring a certain fire rating for wood, but what they're gonna say is for gypsum protection, in other words, non-combustible protection, for 4A, if you need something that has a 3-hour rating, you still have to put minimum 3 layers of 5/8 type X gyp. If it's a 2-hour rating or less, you have to put 2 layers of 5/8 type X gyp. Now, that doesn't give you the full 3 and 2-hour rating. The remainder of that rating comes from the char calculations. So it's actually a combination of how much time does the non-combustible gyp membrane give you. Once the fire penetrates that, how much additional protection are you getting per char calculations? That's what you have to do. 4B construction says, hey, it's the same as for 4A, except in the places where you expose the mass timber where it is allowed to be exposed. You just have to get 100% of whatever the fire rating is through your char calculations. And then 4C construction says all mass timbers permitted may be exposed except as noted. And again, that was the shafts and concealed spaces, that type of stuff. We have a real good resource then. If you'd like to read up on this, it's on our website. It's called Tall Wood Buildings in the 2021 IBC. It's basically what this presentation was based on, goes into much more detail. It's written by one of our technical directors at Woodworks, who's considered our mass timber expert. When you call me with a question on mass timber and it stumps me, I go to Scott Brenneman. He's one of the real gurus in terms of mass timber at Woodworks. But this is available for a free download on our website if you'd like to check it out. So we're going to wrap it up. How's our time doing? Perfect. We got 2 minutes left, and we have about 2 or 3 slides to go here. So early tall wood code adoption in California. Like I mentioned, back in August, they voted on this at the California Building Standards Commission. It was passed unanimously. Those changes were scheduled to be published in the new 18-month revision to the 2019 CBC on January 1st of 2021, which has already come and gone. I haven't been to the website to see if you can actually purchase it yet, but theoretically, it's supposed to have been published. And then it will become adopted and effective on January 1st of this year. Here was Chief Mike Richwine from the State Fire Marshal. He had 3 things to point out about why California wants to be early adopters of these tall wood provisions. One of them has to do with essentially all this tall wood stuff, the mass timber, cross-laminated timber, nail-laminated timber, even glue lams, all of that is made from small pieces, okay? So if we could get a CLT manufacturing plant here in California, which we don't have right now, this would really help our economy. So they want to spur mass timber production in California. So keep your fingers crossed. We hope to get some actual manufacturers here in California. This kind of goes hand in hand. Go ahead,
Mark. Are the closest ones right now?
There's a number of them up in the Pacific Northwest, Portland, Spokane, that area, across the border. There's one, I think 2 in Spokane, but there's one in Montana, and then one down in Dothan, Alabama. There's 3 more that are up in Canada. So nothing within 1,000 miles of us here. Probably the closest is coming out of Portland. But this item 2 here, what California has realized is we've been taking a reactive approach to all these fires. We don't let Mother Nature run its course like she normally would and have a fire every 20 years, and that thins all out, all the undergrowth, but it doesn't burn the tall trees. It doesn't get up to the crown of the forest. We prevent that. We actively prevent that. We let all that fuel load build up. So when we get the Paradise Fire, like we did have this last year, it burns all the way to the crown. It's like a towering inferno, and it'll destroy towns. So what they realize is, let's be proactive. Let's spend money thinning these forests. We can't tell people you can't live in the forest, but if you do live in the forest, it's the next best thing we can do is let's thin the forest around there. And so what do we do with all that wood? Well, he realized if you're making all this mass timber out of small pieces, there's a market for it right there. The third thing, and again, I've talked about this, the carbon
Sorry,
footprint.
I keep interrupting
okay,
so much.
That's okay.
Did that occur naturally before the sort of fires that we had cleared out the underbrush?
Absolutely.
Without it? And I'm curious why those types of fires no longer occur.
Because we prevent them. That's the problem. They have documented history.
Who is preventing those?
People. The way nature did it was these fires would come, they'd blow through. Nobody could prevent them. A forest fire, they could try to put out one building or something, but you basically couldn't stop the forest fire. It didn't have the technology. Lightning strike, it's 100 miles from anywhere. It just does its thing. It runs its course. It burns out the undergrowth. As we started moving there and populating these places and getting the technology, now we're doing our darndest, spending millions to stop these fires. Don't let them spread, okay? We're stopping Mother Nature, and that's what's happening. So We can't say, oh, time out, nobody can live in the forest anymore. We all have to move to the city. Can't prevent that. But what we can do is if we thin the forest, we prevent the fire from getting so out of hand that it reaches the crown. And now it's burning these 24-inch diameter trees like matchsticks because it's so hot. So that's what this is really all about. Interesting.
Wondering though, certain forestry services and national parks, I think, do set fires to mimic, but it's probably a lot less widespread than was occurring previously. And if there are others actively trying to stop it, but I'd imagine that those at national parks and stuff are following good recommendations about what to do. But
there's been congressional things passed that says we can't touch the old growth lumber. Okay, that means you can't do controlled burns, but you use the term forestry. Practicing good forestry practices is doing that. That's one of the things that forestry does is we will set fires. We'll control it. We'll do it in areas where we can control it, but that is a way of doing it. But you can't do that everywhere when you're right up against buildings and things, houses. So that's a type of good forestry practice. And I'll say since the start of the 1900s, is that the 20th century, I guess, when we really started practicing forestry, our even though we harvest a ton of timber and use it for building materials, the size of our forest hasn't changed. We plant one tree for every three, or 3 trees for every one that we harvest. We do all these good forestry practices. So I know tree huggers and all, they're mean well, but a lot of those people are misinformed. They think that when you harvest wood, it never grows back and we're just raping our forest. Not the case at all. All our forests are well managed with good practices in forestry, letting them regrow. We don't let them go to 100 years so we can get 24-inch diameter, stalks and we can cut big columns out of that. We harvest them when they're 14 inches and get small pieces out of it. But that's good forestry practice. Okay, so I think I have 1 slide left here. No, 2 slides. So basically, here's the differences with CBC. What we've always done, and it's no different for tall wood, is we treat these 6 occupancies differently than IBC does. A, E, H, I, L, and R. And I should say L doesn't even exist in the IBC. That's laboratories. That's a California-specific occupancy. But if you have an A, E, H, I, L, and R occupancy, CBC will treat it differently than IBC. And basically, the first one is the double dipping exception. So normally when you add sprinklers to a building, you can take both a height and an area increase. Height is usually 20 feet and 1 story. Area is 3 times the non-sprinkled base area. IBC says we don't care what occupancy, you put sprinklers in, you get to take a height and an area increase. CBC says that's fine for some occupancies, but if it's A, E, H, I, L, or R, you can take either a height or an area. You can't take both of them together. Likewise, the difference between CBC and IBC when it comes to the total building area, IBC says for all occupancy types, for a 2-story building, or actually, let's say a 3-story building or more, you can only multiply the floor area by 3, okay? But CBC says that's fine for some occupancies, but if it's A, E, H, I, L, or R, now you get to take the allowable floor area and only multiply it by 2, okay? So there's kind of a double whammy here. If you're one of these A, E, H, I, L, or R occupancies, you can only multiply the floor area by 2 to get the total building area, and you can't take both the height and the area increase. You're going to be limited to one or the other. So what we see happening with tall wood, and the same things apply in tall wood in terms of double dipping, allowable area, what we see is most designers in California will forego the idea of grabbing the extra 20 feet and the extra story. Remember I mentioned 18 stories, 270 feet. They'll go with the California option, which would be 17 stories, 250 feet, but now they get to take the area increase. So you can get a much larger area and therefore larger volume building if you forego that extra story and the 20 feet of height. If you're dead set on the extra story and 20 feet of height, then you're going to have to go with smaller area building. And particularly when a large tall building, that's really restricting you. So again, that's what we see coming down the pipe, is most California designers will not be grabbing the limits of the upper height area. And here's my final slide. This wraps up the presentation. This is not all of the occupancy types, but just some examples. And it's not all the construction types either. It's just kind of to show you for comparison purposes, but it's clearly 4A, 4B, and 4C in the center area. Anything that's red is a California specific number. So if it's for IBC, IBC doesn't care about A occupancies. They say for any of these, you can go, let's say 4A, go 270 feet, 18 stories, 135,000 square foot per floor without a frontage increase, you're good to go. California says, oh, if you want to take that 135,000 area increase, now you're going to be limited to 250 feet and 17 stories. If you're dead set on 270 feet and 18 stories, now your allowable area per floor is 45,000 square feet. Same thing applies for the other construction types here. You can kind of see how that goes down. So with that, I spilled over just a little bit there. Anyway, I'm open for questions now. So Robert, I don't know if you would like to, had anybody put any questions in the chat box? I didn't even look at it, but.
No, I don't see any in the chat yet. So if anyone has questions.
If you'd like to unmute and just talk to me, I'm totally fine doing it the old fashioned way. And if you can allow them to turn their cameras on and I can see their face, that's even better. So anyways, any questions? California or IBC?
Hey, Mike.
Hey, Guillaume.
Hi.
Good to see you.
Nice to see you. Thank you for the nice presentation. It's been very instructive as always. Looking forward to full implementation of the IBC 2021, so we don't have to go through the hassle of early adoption. We've been involved together in a building in Culver City that has been qualified as type 4B, and we're trying to get the early adoption of IBC 2021 to have it as a type 4B because we're going to want to have exposed CLT. And the question that came up on that building is, of course, the architects want to be exposing almost the full extent of the ceilings rather than limit themselves to, I think, 20% of exposed mass timber.
But you can't get 4C to work doing that because you're outside the height and area.
Well, we cannot use 4C because we're above 85 feet in terms of building
height. The height and area. Yep.
So we had to be 4B, and then we're going to have to basically go through alternate means and method to show that we can expose more than 20% of our ceilings without compromising the fire safety. So do you have an idea of what would that alternate means and method proof and documentation would look like for
here's what I would suggest. And again, I don't have a lot of personal experience with this because we have nothing in this area, but there are two buildings that are actually under construction now in the United States called the Intro building in Cleveland. I believe it's 9 stories, 115 feet. And the Ascent project in Milwaukee, which is like a 19/6. It's 25 stories, 285 feet tall, mass timber building. Both of those are exceeding the allowable limits, even under the new code provisions for exposed timber. So both of those are being done through the AMMR process. And they certainly took some extra steps, whether that meant enhanced sprinkler systems, additional exits. I don't know what they use per se, but the advice I can give you and anybody who's interested in this, just total coincidence, we had a webinar on Woodworks today. It was at 10 o'clock this morning Pacific time on the Intro and the Ascent project. And every one of our webinars is the presentation slides are contained in our website. We have a webinar archive. So if you go to our website and you look under education, click down, find webinar archives, you ought to be able to click on that and you could actually view the presentation that happened today. And that's exactly the kind of stuff they talked about. Here's what we did on Intro. Here's what we did on Ascent. And both of those are exceeding the allowable amounts of exposed. Mm-hmm. And obviously, Ascent it's at 280 feet. That's above the 270-foot limit. It's 19 stories above the podium. That's above the 18-story limit, even within 4A, and yet they're exposing some of the mass timber. So that's really pushing the envelope. But that's what I would recommend. You check out that webinar. Yeah, it's free to download it. But that's the type of thing that they'll be discussing in that webinar. I didn't have a chance to look at it today, but
is that webinar available on the website, Mike?
Yeah, woodworks.org. And again, if you, I'm screen sharing. Let me just, I'll show you right now. Let's see. Okay. No, what I do want to keep sharing. Windows closed. Okay, I'm going to go back to, pardon me for just a second. I'm going to go to that website. And okay, let me open this up. Education. Okay. Oops. Zenaida, I'm going to go back to screen sharing here.
Sure, thanks.
Okay, so here we are. Okay, so here's our website. You go to the education tab here. You drill down. Here's every presentation we've ever done, third party included. Here's our webinar archives. Now, I can't guarantee, I'm going to click on this. Yep, this is today's webinar today, A Tale of Two Timber Towers. And you can see two of the nation's first tall mass timber towers currently under construction. This is intro and ascent, free download of this. And so this is accessible from our website. Again, education tab, webinar archives.
Great.
Okay.
We'll pick it up.
Any other questions?
I was just wondering if anybody has any experience working on this type of buildings in the LA area or California, or if anybody has gone through this special way of meeting the requirements or waiting on the adaptation of the code to submit for such buildings. If anybody is
and I'll share my part of it that I know of. The project I briefly mentioned where they want to do a 12/2, we went to the LA, specifically LA Fire Department, the fire marshal, and talked to them about doing it. And we said, hey, this is coming in the IBC. They're interested in doing it under the AMMR process. But what the fire marshal's response was then, and this was 18 months ago, he said, we won't even entertain the AMMR because we know California is going to be different. I don't care what testing you do, we're not going to let you do something under the IBC without knowing what CBC is going to adopt. But what they admitted was once CBC publishes what the new provisions will be, they will absolutely entertain the AMMR because then they know what the guidelines are. So that has actually happened now. As of January 1st, those tallwood provisions have been published. They're not adopted yet, but if LADBS holds true to their word, they will let you entertain a tallwood building using the precedent of the now published CBC tallwood provisions. If you wait till July 1st, you don't even have to go through the AMMR process because it'll be adopted in code. But there are no, approved tallwood buildings in Southern California. Like I said, I don't even know that there's any in California. There's some in design, but nothing definitely built or anything at this point in time. But people are talking about it, so it is coming.
Sounds promising, yes. And do you know if City of LA is going to be adopting the CBC just word by word, or are they going to be working on any amendments?
No guarantees, but it sounded like, they will undoubtedly have their own little tiny tweaks, but I don't think they're changing anything major. The big threat to that, and I don't know if you're aware of it or not, Will has probably heard of it. There is a movement, and I won't, because I'm biased, obviously, I won't share who's behind it, but there is a movement to reactivate something that's it's a 1918 provision in LA that created some fire zones that basically said in the central corridor of LA, we're going to create this fire zone because these are the most important buildings, the downtown area. We don't want them to be combustible. You can't use wood. Okay, so there's a movement afoot to say, we don't want wood anywhere because all the poor, impoverished neighborhoods, you're being discriminated against. The rich people that work in the tall buildings get this extra protection. They let your houses be built out of anything in wood. So what they're pushing for is the only kind of wood you can use is type 3 construction, where you're using fire retardant treated studs on the outside walls. You cannot use type 4 construction, which means the new three new types of type 4 construction, if anybody does ever, if they're successful in getting that fire zone thing reactivated, then LA won't be able to do the new tall wood provisions, because that's what mass timber is, type 4A, 4B, and 4C. It's within type 4.
Oh.
So that's the only the solid thing I can tell you about that. But other than that, I'm not aware of them considering any changes to it or whatever, although they may tweak it slightly. But for all intents and purposes, I would assume that on July 1st, you guys will be able to do it.
And when you say it's by fire zones, would that be pretty much de facto everywhere in LA, or?
It's almost all of LA. It goes all the way out to the coast. And Will, you may know more about it than I do. I don't get involved in that. They have lobbyists, whatever. Our job is to, educate and help you, not to fight the political battles.
Yeah.
I definitely have my opinions. I know who's behind this. I'm not going to.
Mike,
Yep.
Thank you for sharing that with everyone. It is indeed something that's on my radar. I would absolutely love more architects to become involved with this. Reach out to me, reach out to the AIA. It's on the council file index. It's something that is, most likely has been delayed because of the pandemic. However, I think we should definitely educate our council members on why this approach is not necessarily the smartest approach. And you're right, Mike, there's a concrete organization.
You said it. Yeah. I didn't say it. I didn't say it.
There's a concrete organization that's attempting to really push this through from an equity point of view, but obviously every building is different, every neighborhood is different, and they all deserve considerations for whichever building type is most suitable for that project. And so I encourage everyone on this call that's interested in this, please connect with me. Maybe the Building Performance and Regulations Committee could kind of take a deeper dive into this.
Definitely.
It's something that has been on the radar of the Central City Association and several other organizations. AIA Los Angeles, we are able to lobby the city. I have to pay all this money to lobby the city. So I would love your input and I would love your support. So thank you.
And that's what it really needs, is the feet on the ground people like architects. That's your regular practice.
Yeah.
Those are the people that need to stand up and say, time out. This is not a good idea.
Yeah, I'm actually really glad that you're bringing this up, because Mike, you're saying that you don't want to get involved in the politics, but I think that one of the goals of this committee is to use it as a platform to see if there's any change that needs to happen, that we can be part of that.
Yep. Or prevent bad changes.
One of the previous subcommittees, I think, that this group had regularly met with LADBS, and so not just that issue, but if any of you hit up against issues that you find a little bit backwards or frustrating, you can share, especially if you have a constructive solution, please share those with us, and we're happy to start trying to bring those to LADBS to get them fleshed out if there's.
And particularly like when they have city council meetings or plum committee, that's a lot of this been in front of the plum committee. They want to get people testifying in front of it. The whole wood industry got kind of bushwhacked when this first came out, because they had like 30, 40 people. These were construction workers in their boots and everything, all pushing for this. Nobody was there from the wood industry because we didn't know about it. The problem is, and I was asked to go up there and testify. That does not look good for me, who works for a company called Woodworks. That's, don't take that. What needs to be is architects, builders in the field who they have a choice of what material they use, but they don't like this idea. So if you guys get up and testify, that holds so much more sway than me testifying.
Makes sense.
Anyway,
Well,
that's a whole can of worms.
I'll
didn't mean to
definitely
open
sign
that.
up for that, Will. It's a shame that they're claiming it's an equity issue when in reality it's more like a monetary issue for that industry. So
You said it, not me.
I didn't say, I said that industry.
Like I said, you said it, not me, but I'm thinking it.
Yeah, a lot of us are, I think.
Anyway.
Any other questions for Mike from our attendees?
Nope. Okay, well, I'll throw one other thing out there for you. It's not tall wood, but in case anybody is interested in actually seeing a CLT building under construction, if anybody's familiar with Bellsberg Architects, their office is down on Main Street in Santa Monica. They're building a new office about 3 blocks up. I believe the address is 2740 Main Street. And they are literally flying CLT panels, at least as of a couple of weeks ago. And I don't know if they're still exposed. I assume they are. But if you're willing to get in a car and venture outside your home, 2740 Main Street, Santa Monica, you might see a good CLT building in your own backyard.